Hello everyone, my name is Aysel Panahova, and together with my teammates Garib, Shahmar and Ravan, I'd like to welcome you to our senior design project presentation. So the project we built is called PANOPTES, which comes from the Greek methodology, and the meaning of PANOPTES is actually all-seeing. So PANOPTES is a platform that lets you monitor your entire infrastructure from only one place. So the idea behind the name and our motto is very simple: see everything, miss nothing. And that's exactly what we are going to show you today. So let me show you, before we dive in, let me quickly walk you through what the next 20 minutes will look like. So I will start off with the project overview, basically what the problem we solved, what we decided to build, and why it actually matters. That will take about 2 minutes. After that, my teammate Gary will talk about the key technical challenges, the hard problems we had to think through and solve. And then Shahmar will go deep into how we actually built the system, the infrastructure, the tools we use, and how everything connects. And finally, Ravan will then show our results, what we measured, what worked, and a quick demo. And finally, we will close together with our individual contributions and what we'll do next if we continue the project. So now we will go with the project overview. Let me start actually with the problem that inspired this whole project. There is a story. So think about a company or even a university lab that runs servers, applications, and services. At any given moment, things can go wrong. A server can crash, an application can slow down, a container can stop responding. When that happens, the operations team needs to figure out what's wrong and in a fast speed. But here's the issue. Today, most teams are using many different tools at the same time, and one tool for server performance, another for logs, another for containers, and none of these tools actually talk to each other. So there is no integrity. So when something breaks, the engineer has to open tool after tool, jumping between dashboards, trying to piece together what happened. And we call this the problem of scattered signals. And the information exists, but it's all over the place. And this leads directly to the second problem, which is slow incident response. And engineers are wasting minutes, sometimes even 10 minutes, 20 minutes, just to navigating between tools during an outage. And in production environments, every minute actually matters. And the third issue is that there is simply no unified view. You can't open one screen and see the health of your servers, your containers, and your applications all at once. You always have to go looking. And fourth, maybe most frustrating one, is that problem is that teams are reactive instead of proactive. What that means is that most of the time, engineers find out something is broken because a user complained, not because the system warned them first. By the time the alert actually fires, if it fires at all, the damage is already done. And these four problems together point a picture of infrastructure monitoring that is fragmented, slow, and blind. And that's exactly what PANOPTES was built to fix. So let's talk about what we set out to do and our objectives and who exactly we built this for. We had 5 main goals. The first one to unify metrics and logs in one platform. And instead of having separate tools for each type of data, we wanted everything. Servers, stats, container data, application logs, and everything visible in one place. And the second was to provide real-time dashboards. We will show this in our next presentations, or next video. And not data that refreshes every few minutes. We are talking about live up to the second visibility into what your hosts and containers are doing right now. And the third objective was automated alerting across multiple channels. So when something goes wrong, the right people should be notified immediately, whether that's through mail, Slack, or a message to their phone. Like no manual checking required. The first was to build everything on an open source, self-hostable stack. And this means anyone can download it, run it on their own servers, and pay nothing in licensing fees. So no vendor lock-in, no subscriptions. And the fifth one was to validate the platform through realistic simulation, meaning we didn't just build it and hope it worked. And we actually stress tested it with simulated incidents to prove that it performs correctly. Now, who is PANOPTES actually for? So we designed it specifically for small to mid-scale environments. Think of it like startups, university research lab, and hobbyist home lab setups. And these are teams that genuinely need proper monitoring, but for whom commercial tools like Datadog or New Relic are simply out of the budget. These platforms can cost, like those that I talked about, those platforms can cost hundreds or even thousands of dollars for a month, but PANOPTES gives those same teams production-grade observability for free. And our vision is a world where every team, regardless of their size or budget, has a complete clarity over their infrastructure. And our mission is to deliver an open, unified platform that takes raw data signals and turns them into clear, actionable information. With that, I'll hand it over to my teammate Garib, who will take you through the key technical challenges we faced while building the PANOPTES.
Thank you, Aysel. My name is Garib. Now that you understand the problem, let me tell you what made building the solution actually hard. Because this wasn't just about plugging tools together. Every decision we made had real consequences. We faced 6 real engineering challenges. The first was heterogeneous sources. Server metrics, application logs, and containers that all speak different languages. Different formats, different intervals, different protocols. Getting them all into one unified pipeline required careful design from day one. The second was scale. At peak, the system processes thousands of data points every second. The storage layer has to handle that efficiently without becoming a bottleneck. Third, the pull versus push trade-off. Prometheus works by pulling data from targets on a schedule, but some signals work better when they push data to the collector. Deciding which approach to use for which signal was a real architectural decision. Fourth, alert fatigue. A monitoring system that sends 200 alerts a day is almost useless. Engineers stopped paying attention. We had to build intelligent grouping and thresholds so that every alert that fires actually means something. Fifth, reliability of the monitoring stack itself. If PANOPTES goes down, nobody knows anything is wrong. That's the worst case. We had to design the system so it doesn't become a single point of failure. And sixth, and final, reproducible validation. We couldn't test on a live production system. That's too risky. So we built a simulator that was its own engineering challenge, and it was essential for getting real, measurable results. Every one of those challenges forced us to make a choice. Let me walk you through the key decisions. For storage, we chose Prometheus TSDB over InfluxDB. Prometheus has native PromQL support, a well-understood pool model, and much lower operational overhead for a team our size. For log aggregation, we chose Grafana Loki over the Yelka stack. Loki uses label-based indexing. It's lightweight and affordable at our scale, and it integrates perfectly with Grafana. For visualization, we choose Grafana over building a custom React interface. Grafana already has everything we need: major dashboards, a rich plugin ecosystem, and it saved us weeks of development time. For alerting, Alert Manager over inline rules. It handles the duplication, grouping, and multi-channel routing, things that would take a long time to build from scratch. And for validation, simulated workloads over live production testing. Repeatably safe and measurable. Every decision came down to the system, the same question. What gives us the best result is the least complexity. And now I will explain the dashboard and this UI of the Grafana. When we go to the URL of this, we welcomed with Grafana. We go to dashboard here from navbar. We see the currently running services here. We have Active Directory and DNS line. Currently it's not usable. Alert Manager overview. If we go into it, we will see the alerts in detail. We have the alerts currently running, firing. We see the, for example, disk space warning or disk space critical and the severity of these warnings, alerts. We see alert timeline here when the alerts happened in detail, notification success, failure rates, and total firing alerts here. Then we go to Docker containers. We see all the Dockers used in the hosts and their usage limits, usage timelines. We see all the Docker containers here, for example, Grafana, Promptail, etc. We see memory usage, CPU usage, and network input-output. Then we go to infrastructure overview. We see here all the hosts, all the alerts, active services, etc. This is the overview of the project. Currently, which memory usage happening. Then we go to Log Explorer. In Log Explorer, we see the logs from the connected hosts. These logs, for example, PAM service ignoring max retries, etc. These are online logs. We can select here refresh timeouts or last, for example, we say 5 minutes, it will show the last 5 minutes logs. Then we go to dashboard again and go to node detail, for example. We see each host name, each logs or each graphs for categorized by host names. We, for example, choose here Cedar PC2 or Cedar PC4 or the PANOPTES host and their uses. For example, CPU usage, each CPU, which CPU uses which percentage, etc. Here we see memory usage and, for example, TCP connections, network, how much network it uses, bandwidth, etc. Then we go dashboard again and we see the projects, servers, metrics or system health. For example, we go to custom metrics. We see that all the services is up and valid. If one service is down, it will show up here and we will be able to fix it quickly. Then we go to system health, for example, PANOPTES, and we see the overview of the health check of the server of our project. And in general, this is the dashboard of our project. Currently, I am in PANOPTES dashboard, specifically node detail panel. Here I chose Cedar PC2. We are going to demonstrate something. My friend Ravan will execute a script.
Yeah. Right now we see that we just two services, and we are right now using a bash script which starts the infinite busy loop in order to increase the CPU usage. And now
It started.
yes, it started, and our services has increased, and we will observe the increased CPU usage here.
Let me expand it. Here it started to increase currently.
Yeah, as you see, CPU usage increasing constantly. We observe the high usage. When I kill the process here, we will see the decrease there. Let me run that. Overkill process, yeah, kill bash. And now we see that again we have just the two process, and then it will start to decrease the CPU usage.
Currently you can see the details of each CPU. It's 35% used currently.
We need a little bit time. Yes, it's now stable and it will decrease then. Yeah, right now we see the fall in the CPU usage. It starts to decrease.
I will now hand it over to Shahmar, who designed the architecture and will show you what we actually built.
Thank you, Garib. My name is Shahmar. As the person who designed the overall architecture and wrote part of the code, I'll now show you how all these decisions came together into one working system. So this is PANOPTES. At a high level, the data flows from left to right, from raw signals at the edge through collection into storage and up to visualization and alerting. Every layer has one clear responsibility, and every component talks to the next through well-defined interfaces. So let's walk through each layer one by one. You can think of pipeline layers as you can think of it as five-step factory pipeline. Raw data goes in one end and useful alerts come out at the other. So step one is the sources, of course, maybe Linux servers, Windows machines, Docker containers, and etc. These are the raw signals, the ground of basically the truth of what's happening in the system at any given moment. Step two is exporters, like Node Exporter collects server statistics, CAdvisor collects container statistics, and Promptel collects logs. This translates raw signals into a standard form that the rest of the systems can understand. Step 3 is the storage. Metrics go into the Prometheus TSDB and logs go into the Grafana Loki. Both are fast, efficient, and most importantly free. Both use label-based indexing, so queries stay quick even under load. Step 4 is visualization. We're using Grafana for that. It reads from both Prometheus and Loki and displays everything together in one unified dashboard. Server health, container statistics again, and application logs all are on the same dashboard, on the same screen, at the same time in real time. Step 5 is of course the action, and when something goes wrong, Alert Manager fires a notification. It deduplicates the alert so you don't get the same message many times, and it groups the related signals together and routes it to email, maybe Slack or your Telegram bot if you have configured one. So about the technology stack, every single tool is open source and free. The collection of our stack is simple: node exporter, C-advisor, Promptail. For the storage, as I mentioned before, we're using Prometheus and Loki. For the visualization, it's Grafana with 10 custom dashboards, if I'm not mistaken. For alerting, Alert Manager with Slack, email, and Telegram bot. We also support webhooks for customly managing how you will be getting those. For the orchestration, it's Docker and Docker Compose, and for the validation, we are using a custom simulator I built in Python and Bash. One thing I'm proud of is the entire stack deploys and kind of runs with one single command using the Docker Compose, and that, yeah, basically that. Coming to the Telegram bot, as you can see, our Telegram bot here, we have Ravan built the integration, and the results during the testings were actually impressive. Here's the flow. If a server goes down, for example, Prometheus detects the failed script within the 30 seconds time frame, and Alert Manager confirms it's a real problem, not a temporary blip, and it fires the alert. The alert hits our custom webhook, and the bot formats the message, and it kind of loads in the team's Telegram group in under 5 seconds. This message tells you exactly which server is down, how long it's been down, and the severity level of the issue. The whole on-call team sees the problem simultaneously, and it costs absolutely nothing because the Telegram bot API is completely free. That 5 seconds detection to phone speed is the difference between a 2-minute fix and the 2-hour disaster you can have. So I'll now hand over to Ravan, who will share our results and close the presentation.
Thank you, Shahmar. My name is Ravan. I will wrap up the presentation by talking about what are the results and achievements of our project and what each of us contributed and where this project goes next, and one thing we want you talk away with. Now, as you see, the table shows the objectives and evidence of our project. It satisfies the unified metrics logs, and we have applied single Grafana workspace with mixed data source, then real-time dashboard, which is the sub-second refresh on hosts and containers panels, and then automatic alerting, which is a multi-channel routing, email, Slack, and webhook. And our open source stack, which is zero proprietary components in the pipeline. And the last one is the validated via simulation. PANOPTES was built by the 4 people, each owning a clear and distinct part of the project. Let me give each teammate a proper credit. Aysel kept the whole project organized and on a schedule and coordinating between all of us. She was managing deadlines and making sure our documentation was professionally and done and it's complete. She also handled the UX and UI improvements, making sure that the dashboards were clean and easy to understand for someone who does not have the technical knowledge. Shahmar was our architect and the main developer. He made the core technical decision which helped the entire platform. It included which tools to use, how to connect them, how to manage the data flows from the source to the screen. He also wrote the majority of the code base. Garib is team leader of our group. He focused on testing and integration. He didn't just test on a laptop. He deployed and verified the PANOPTES on real CEDAR PCs. And that's completely different challenge because it's from the local setup. And he found the compatibility and fixed them and make sure that the system actually works outside of the ideal conditions. From my side, I focused on the 2 things: system testing and Telegram bot integration. On the testing side, I ran the system through failure scenarios to verify everything behaved correctly. On the Telegram side, I built a webhook receiver which connected to the alert manager, and it helped us to make sure that alerts reached to the team phones in under the 5 seconds. That's what is now one of our most important features. In general, I would say that every role matters, and can say that the great architecture means nothing if it is not tested. Also, good alerts mean nothing if nobody receives them. And the working system means nothing again if it is not documented and organized well. And what we can do in the next, right now PANOPTES works well, but we already know that what we would build the next. The most natural next step is the distributed tracing, for example adding tools like Tempo or Jaeger, so we can follow the single user request through every micro services. Right now we see system health tracing will show us exactly where requests slowed down or failed, and ML-based anomaly detection would replace our fixed alert threshold. And instead of saying, for example, alert if CPU goes above 80%, the system would learn what normal looks like for each server, and then alert when something unusual happens, even it hasn't crossed the hard. Multi-tenancy would let the different teams share one installation, but see only their own data. For example, used for university environments or companies with multiple departments. And to come to the edge collection, we can say that it will bring the lightweight agents to IoT devices and constrained environments where a full node exporter can be too heavy. And auto remediation is exciting because when alert fires, instead of just notifying a human, the system automatically runs a fix or restarts their crashed service, scales containers, or roll back a bad deployment. And overall, I would say that the one thing we want you to remember from today, PANOPTES right now proves the production grade observability can be open, unified, and accessible without compromise. And you don't need to spend thousands of dollars on, for example, Datadog or a New Relic. With a right open source tool, by using architecture and team, we can take ownership of our work, and any team can have a full real-time visibility into their infrastructure. This is what we built, this is what we proved. Thank you all very much for your time and attention. We're happy to answer your questions.